Hey guys, so our next set of lesson videos are going to deal with what we call conic sections. So hopefully you had a chance to watch the little intro video that kind of showed you how the different conic sections are formed. So a conic section, as the video kind of showed you, is a figure formed by the intersection of a plane and a cone. And depending on how that plane slices that cone, that depends on what conic section is going to be formed. Here is the general formula for all conic sections. So this formula, obviously these letters will be replaced by constants or numbers, and the way that this formula looks is going to help you determine the type of conic section that's being described. So this won't seem as overwhelming as it does right now. For right now, just keep in mind that if you have a general formula, if it's a circle, the a value and the c value are the same. So in other words, the coefficient of the x squared term and the y squared term are the same. And they're usually 1, but they have to be the same. So circles is the conic section for today. You guys probably remember a little bit about circles from geometry. So just as a refresher, a circle is the set of all points that are equidistant from a given point, which is the center. So remember, you got your little circle, the center, the distance all those points are away from the center all the way around, you may remember it's called the radius. What is the standard equation of a circle? So the standard equation of a circle looks like this. X minus h squared plus y minus k squared equals r squared. And in this equation, hk is the center and r is the radius. So if this kind of looks familiar, guess where this comes from? This comes from the distance formula or the Pythagorean theorem. So it has to do, it kind of goes back to like the unit circle, making triangles. This distance squared plus this distance squared equals the radius squared. Just for what it's worth, where the formula comes from. So that's what the equation looked like. So first we're going to start by doing a few examples, just if we're given an equation, identifying the features. So our first example is identify the center and the radius of the following. And we've got x minus 2 squared plus y plus 4 squared equals 81. So if we go back, put it so you can see both of those. This is our standard equation. So if we kind of compare that to what we have here, our center, so notice the center is always subtracted from the x and the y. An easy way to remember it is just take the opposite sign. So in this case, our center would be 2, comma, negative 4. And then our radius, so remember, it equals r squared. So since this equals 81, our radius is going to be the square root of 81, which is 9. And then, of course, if you wanted to, you could graph it from there. Just graph the center and then count out 9 in each direction. Okay, what about if we're working backwards? What about if we want to write the equation if we have a center and a radius? So again, we're going to reference our little equation guy. So my center is 1, 4, so that's going to be x minus 1 squared. And then my y value, my center, my k is 4, so plus y minus 4 squared. And then we always know it equals the radius squared. So since my radius is 6, this guy is going to equal 36. So that's the basic idea of how the equation works, which you may, like I said, you may remember a little bit of that from geometry. So what about if we have a center and we have a point on the circle? So let's take a look at an example of that. This says write an equation of a circle with a center of negative 3, negative 5, and it passes through the point 1, negative 2. Okay, so if we go back to our equation, here it is. So we know the center, we know a point, but we do not know the r. Okay, so let's just plug in what we know with the center. So since the x value, my center, is negative 3, I'd have x plus 3 squared. Since the y value of my center is negative 5, I'd have y plus 5 squared. Okay. The problem here is we do not know the radius. We are not given that. So we're just given the center and a point on the circle. So what can we do to get the radius? Well, if we have this point, okay, remember all points, all pairs are written in the form x comma y. I'm just going to plug this in for x and this in for y, and then I'll be able to use that to figure out what the radius is. So I'm going to plug this in here and this in here. So that's going to give me 1 plus 3 squared plus, and then in for y I'm putting in -2. -2 plus 5 squared equals r squared. Okay, well 1 plus 3 is 4. 4 squared is 16. -2 plus 5 would be 3. 3 squared is 9. So 16 plus 9 is r squared. So what does that tell us? R squared must be 25. Which, if r squared is 25, the radius would be 5. But remember, our goal is to just write an equation. And in the equation, you already have r squared. So there's really no need to take the square root of that. We can just plug it in. So then our equation, okay, so we're just going to go back up to here where we had this and we just didn't know the r, and just plug in the r. So my equation would be x plus 3 squared plus y plus 5 squared, which we already knew from the center. So that's a plus. And then now we know it's going to equal 25. And that would be our equation. So it is also possible, if you have the center and a point, to also write an equation. Okay, the next thing we're going to talk about is, what about if that equation is not in that standard form that we just talked about? So if the equation is not in that standard form, the form that we like to have it in, we will need to remember to complete the square. Okay, so if you don't remember completing the square, that's how you take an equation from general form to vertex form for a parabola. I'll refresh you on how to do that here. So example 3 says identify the center and the radius of this equation. So this is kind of going back to this, this general form thing that I kind of referenced at the beginning. So where you're going to see these big ugly looking equations. So the main thing to point out is how I know this is a circle. Right now I'm telling you it's a circle, but I would know that this is a circle because the coefficients of the x squared and the y squared are both the same. In this case, they're both 1. So that's how I know that it's a circle. Okay, so A equals C. So what I'm going to have to do is I'm going to have to complete the square. So to complete the square, the first thing I'm going to do is group the x terms together, group the y terms together, and then complete the square. So I'm going to put the x terms together. So I'm going to do x squared plus 6x, and then I'm just going to leave a little blank. My goal is to make this a perfect square trinomial. Why? So that it factors into something squared. Remember, we want it to be look like this and this, so we need to create perfect square trinomials. So I group the x's together. Now I'm going to group the y's together. So that's going to be y squared minus 4y. Again, put a little blank. Okay. What I always say is easiest to do is move all the constants or all the numbers to the other side. So I'm just going to move this 12 over here and make that a positive 12 by adding it. Okay, so completing the square. If you don't remember how to complete the square, you may remember you always take your b value and you cut it in half and then you square it. So in this case, I would do 6 divided by 2 squared. So 6 divided by 2 is 3. 3 squared is 9. Now I can't just randomly add 9 to an equation, but since this is an equation, I can do whatever I want as long as I do it to both sides. So if I add 9 over here, guess what? I'm also going to add 9 over there. And then we're going to do the same thing for the y here. So I'm going to take half of my b term. So I'm going to do -4 divided by 2 and square it. So -4 divided by 2 is -2, and -2 squared is 4. So if I'm adding 4 here, guess what? I'm going to add 4 to that side to keep the equation balanced. So it just goes back. You may remember doing it with trinomials. Basically we've created 2 perfect square trinomials. So now I just need to simplify. So on this side, I'm just going to add all of, let's start with the easy side, add all of these together. So 12 plus 9 is 21, plus 4 is 25. So on this side, I get 25. Okay. And then over here, I've created these are going to be perfect square trinomials. So now I just need to factor them. Easiest thing to remember is this is always going to be, this number that goes here is always either going to be half of the middle term or the square root of that term, however you want to remember it. And since these are all plus, that's how I know this is a plus. So this is x plus 3 squared. You could also, if you wanted to, go back and say what are factors of 9 that add to 6? They're 3 and 3. Okay, but like I said, this will always be half of that term or the square root of that term. And then I'm going to do the same thing on the y. So notice on the y, this is a subtraction. So I know it's going to be y minus something. And then same thing. It's going to be either half of this term or the square root of that term. So either way, it's going to be 2. So there is my equation. So now that looks like that standard equation that we were given in the original ones. So now if I have that standard equation, now I'm going to identify the center. So remember, center is just the opposite of both of these guys. So the center is -3, +2. And then the radius, remember, it's always equal to the square root of that number. So in this case, the radius would be 5. So that's how you can take it, get it in that standard form if it's given to you in what we call general form. So we're going to do one more like that. So what I would encourage you to do if you're watching the video is to kind of pause it and try this one on your own. And then once you've tried it on your own, you can go unpause it and go ahead and watch me go through it. So this one, again, I know it's a circle because the coefficients in front of the x squared and y squared are the same. And as I mentioned, if it's a circle, 9 times out of 10, those will be 1. So I'm going to approach this one just like I did the other one. I'm going to group the x terms together, group the y terms together. So this is going to be x squared minus 8x plus a blank, and then plus y squared, 6y plus a blank. And then I'm just going to move that 54 over to the other side. Okay. Now my task is to complete the square. So remember, magic number is you always take half of your b and square it. So -8 divided by 2 squared. So -8 divided by 2 is -4, and -4 squared is 16. Guess what? If I add 16 over here, also got to add 16 over here. Now I'm going to do the same thing on the y's. Take half of that b and square it. So 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 here. So guess what? I also have to add 9 over there. Okay, so now I'm just going to add these together over here just because that's the easiest thing to do. So I have 54 plus 16. So 54 plus 16 is 70. So 70 plus 9, this is 79. And then I'm going to go ahead and factor these. So remember, it's always just half of this number. Keep the sign. So this is x minus 4 squared. This is going to be y, again, half of this number. Keep the sign. Y plus 3 squared. Now I've got it in that standard form. So now that I have it in that standard form, the center of this would be just the opposite of both of these. So the center would be at a +4 and a -3. And the radius, remember, this is the radius squared is 79. So in this case, the radius is just not a nice number. It's the square root of 79. If you wanted to get a decimal approximation just to help you graph it, you could. So the square root of 79 is about 8.89. We know it's really close to 9 since that's really close to 81. So. Okay guys, so that's what the conic sections of circles look like and how their equations look. All right, talk to you guys again soon. Bye.